Okay, so this is our UIL meet for Tuesday, and I know this is a little bit late being recorded, and we did not have any meets last week. We didn't have meets last week because I had a final exam for one of my grad classes that was it was a monster, and I probably spent 40 weeks outside of work working on the final exam. 40 weeks. I'm sorry, I'm still tired from that, even though I slept well last night. 40 hours outside of work working on that exam, and I felt like I wanted to call in sick every single day. But what we're going to do today is we're going to look at more programming problems. And I highly encourage you to follow along in BlueJ or NetBeans or Eclipse, whatever you want to use, whatever IDE you want to use. In fact, I would recommend that maybe you get used to Eclipse or NetBeans. Okay, maybe not NetBeans; it's kind of outdated, but Eclipse is kind of what Java programmers use in a professional setting. So maybe look at Eclipse and see if it works for you. Mess around, create some toy programs in it, and see how autocomplete works. Because with autocomplete enabled, you can save yourself so much time, and it completes code so that when you're stuck, like when you kind of remember what a keyword is or a function called to like string dot equals or whatever. Okay, that's a very basic example. But what that's going to do is it's going to autocomplete for you, and it's going to tell you additional parameters you could put inside of there. And so it's programming only in BlueJ at these programming competitions puts you at a severe disadvantage because you're able to save so much time with the autocomplete just by hitting the tab button or whatever it is for the autocomplete to work. And, time saved is more time you could be spending on other problems. So what I would like to do right now is we're going to work through an example, and we'll see how much time we have after working through, not the example, but a real problem that was at a district meet. And we're focusing on the district and potentially even the regional problem difficulties. But note that as you go up from district to regional to state, the difficulty of the problems actually increases. Because, if all the CS teams that have one district are probably very strong, and many of them are probably scoring perfect or near perfect on these exams, okay? Or within 100 points. And so they make them harder and harder so that there's it becomes easier to differentiate between the winners and the losers. If every test were as easy at each level, the people that are scoring perfects at district or whatever would still be scoring perfects at regional and state, and then you would have like a 14-way tie or whatever at state, and it would be impossible to say who won. You would just have to say, well, there's a 14-place or a 14-way tie for first place, and no one's really happy about that. So they do get harder, but we're going to stick with the district level problems for right now, and then we will look into, as we've done most, if not all, of the somewhat challenging ones for district, then we'll start looking at our regional and state type of problems. So what I would like to look at today is this first problem from the District2 exam of 2010, and this is from this csutexas.edu. It's the released computer science UIL test, and It's like the fourth result when you search that in Google. But I showed you this a few weeks ago, right before break. And so what we're on right now is I opened up this link right here, and I am, in the District 2 exam, okay? And so let's look at this problem. I just opened it up and looked at the very first one, and I was like, yep, this looks like a cool one, okay? So cool in that it's fairly simple, but, it may not be simple, all right? So here we have an input file. So let's go ahead and create this input file. Let me go ahead and check to see where to save this input file first. Oh, it's SAT app. Okay. So I'm going to go ahead and make an input file, new file. And this one is going to be called Armstrong.dat. But our numbers are right here, so I need those. So the first one is 5, 153, 222, 1 0 0 0 0, 5, 1 6 3 4. Okay, so we're going to go ahead and save this, and my directory is under users, dgatewood, and SAT app. And this needs to be saved as Armstrong.dat. And all file types, because I'm saving it as a DAT file. And go ahead and close that. Now we're going to extend this, and in fact we're going to find all the Armstrong numbers between 1 and 10,000, or whatever number you want to do, okay? So here we have 3 Armstrong numbers, and 2 of them are actually the same Armstrong number. And so it might be that there is only 2 between here and 10,000, but there might be other Armstrong numbers, okay? And so let's see here. What is an Armstrong number? An Armstrong number is known as a narcissistic number. Also known as a narcissistic number is a number that is equal to the sum of its own digits raised to the power of the number of digits. Okay? So we take the digits of the number, we raise it to the third power, raised to the power of the number of digits, raise it to the power of the number of the digits, and then we add those numbers up, and that if that number, after adding the result of raising it to the power of its own number of digits, if that number equals the original number, then it is an Armstrong number, okay? So it seems kind of complicated, but it's actually quite simple, okay? So how are we going to do this? Well, it's quite simple. So we're raising it to the power of this. So we're going to use pow. Okay. Whoops. Blue Jay. So I've already, now I'm using buffered reader here, but you can use scanner, and scanner works the same. You could just say scanner sc equals new scanner, and then you put in the file reader file, okay? And so this is not going to be problems.txt, it's going to be Armstrong.dat, okay? And whenever you're reading in a file, you need to either wrap where you read that file in with some kind of exception, or you could just say to the whole method that you're involved with that it just throws an exception, a generic exception, okay? And that's what I did here, just it's easier. Now, if you are doing production level code, you would want it to tell the user exactly what type of exception was thrown and why. For instance, you would want it to show if Armstrong.dat did not exist, you would want it to show a file not found error. Okay, so yeah, what we're going to do is we are going to get the list of numbers. Okay, so I'm going to save it in a string array. So string array str nums is equal to, well, do we want to do that? Because we don't know how many items are actually in the list. Now, when you don't know how many items are in the list, an array is actually a poor choice, okay? Because an array, you need the actual amount, the size of the array when creating the array. Now, that's not true for array list. So what we're going to do is use an array list. Okay, so I'm going to say array list, and then this is going to be an array list of strings. And we're going to say list is equal to new array list okay, and so this makes a list of strings, and yeah. So what we want to do now is we want to read in that file. So what we're going to do is we're going to say while br dot has, well, what do I do? That has next line. So is that not has next line? Let's see here, buffered reader. Now you can't do this during the test, but you can take in a reference material, but you cannot search the internet. So, but I haven't used buffered reader in a long time. So I want to actually look at this, and we're just practicing anyways, but during the actual competition, you would not be able to do this. So buffered reader is, so read line, and that's all buffered reader has. Okay, so read the line of text. So I think I actually prefer scanner. I think buffered reader may be faster, but what we're going to do is we're just going to change this to scanner. Okay, and we're used to scanner. And so we're just going to say SC here. And SC does have this method called hasNextLine. Okay. While sc.hasNextLine, we're going to say list.append, and we're going to append this to the list. Now the list has nothing in it, so it's going to append it in the first spot, and then when we read the next line, that result's going to be appended to the second spot, and so forth and so on. Okay, so we're going to append sc.nextLine. Okay. Dot add, I believe. Okay, so it's really hard. Since I've been in grad school, I used to only do Java, and then I thought my pre-AP classes were getting kind of stale with just Java, so I moved to JavaScript for them. And in grad school, I've been using C and C++, and then also Python, among a few other things. And so it's just like language soup, so many different languages, and they all have, all the structures are the same, but they have different keywords that do different things, and so sometimes I get them mixed up. But anyway, so here we have, add, and this is just going to add it to the list. JavaScript, I believe, is append, and I think Python as well. But yeah. Actually, it's Python that's append, and for JavaScript, it's push. But anyways, that's useless aside. So what we want to do is we have them now in this list of strings, okay? And we want to loop through that list, okay? And we're going to loop through the list, and then we are going to output whether it's a Armstrong number or not. Okay, so what we're going to say is we're going to say for int I is equal to 0, while I is less than list dot size. So for a list, it's different than array. We don't use length, we use size. And then we say I plus plus. Okay, and so here's one deal that we're going to have to figure out. This is a string, and we need numbers because we need to compute those numbers, which it's not bad, okay? So, we want the different digits in the number, so we don't want to just turn it to a number to start with. We want to keep it as a string. It's actually going to be somewhat easier for us. And so we want to loop over the items in the string. Okay, so how are we going to do that? Now we're going to use an inner loop. So we're going to say for int j is equal to 0, while j is less than list.get I dot length. And here we're going to say j plus plus. Okay, so this returns the string at this location, okay? And then this is the length of that string, okay? So if this were 333, that's the string that we're returning. And the length of the string is 3, because there are 3 3s in 333, okay? And so what we want to do now is we want to sum this up. And so here, we're going to create a little thing called sum. All right. And int sum is equal to 0. And here, we're going to get the individual letter from the word. So here, this is going to be list.get at I. And so this is going to return the word. And we're going to say dot substring from 0 to 0 plus from j. Actually, instead of substring, we're just using a single character. So we're going to say char at, and then we're just going to say j. Okay, so char at j. And this is going to return the character that is the number that we want. So this would be the first number in that string, okay? Now, what do we want to do with it? Well, the first thing we want to do with it is we want to get the size of, so we're going to say num digits. This is going to be an int. Again, Python, you don't even have to say int or anything. You just say num digits. Num digits is equal to list.get I dot, well, we could just say this, dot length. Okay, so now we have the number of digits, and this is the power that we're going to raise it to. Okay, and so what do we want to do with this? Well, we want to return this as a number. Okay, so this is going to, we're going to say int num is equal to list. So this is returning a character. And so what we want to do is we want to say integer dot parse int. And we want to parse this as an integer. Uh-oh. So a char cannot be converted to Java lang.string. So how do we get through that? Char at J. I know there's an easy way of doing it. Well, maybe we will just use the substring, okay? Dot substring, it's going to be, and then this is just J plus 1, okay? And this will work just fine, okay? For some reason, char at, I was thinking that it would be an easy conversion to a string, but I'm not thinking completely clearly right now. So here we have this number that has been returned, and what we want to do is we want to raise it to this power, okay? And so here we're going to say int result is equal to, and here we're going to say is it math dot pow, and we're going to say num digits. From double to int. Okay, so that's an easy thing. We could just okay, and then we're just casting it to an int. So this is going to return some double number, and we're going to say, well, I know the result is an int, so I just want you to go ahead and cast it to an int. Okay. Here we get the result, and what we want to do is we want to sum it up. And so we're going to say sum plus equals the result. All right. And then what we're going to do is well, actually, let's see here. We're basically going to do the same thing again. So here, and we'll call this full num. And so this is going to be not substring, it's just going to be list.get at I. Okay, so this is getting the number that we are in the list, the full number. This is getting the digit, each digit within that number. Okay, and so now all we have to do is see if sum is equal to full num. All right, so if sum is equal to full num, we're gonna print system.out.print line. And what do we print? So in the competition, you'd have this available to you. Actually, it's in Word. We would just print Armstrong with a capital A. Okay. Okay, so let's go back to that, and we're going to print all right, and then here we're going to say else now, what if I had a misspelling somewhere in here? Well, if if you accidentally put two M's in here and submitted it to the judges, even though your implementation works, you would get it sent back to you. And the error message or the sheet that is sent back to you explaining why it is being sent back may not be very clear as to what the error is. It might just say the produced results from your program did not match judges' data, okay? And it could be something as small as a misspelling in the output, or it could be that, your program didn't work and it was printing wrong results. So it was saying that 111 was in fact an Armstrong number when it is not, okay? So when something gets sent back, what you want to do is not have the programmer that was programming it only look at the file and say, well, I don't know. You want multiple people to look at, what the output, the sample output that you have is, and compare it to the data within the packet, okay? So you want multiple eyes on that in case it is something as simple as an M, an extra M, or an N in the place of an M, because that may be very hard to see, okay? And I've judged some events where it was a single character that was preventing full points, and they sent it back many times, and we couldn't do anything. It was just like it did not match judges' data. And they eventually gave up, and it was something as simple as a misplaced character, okay? So keep that in mind. It's going to matter, okay? So here, we've gotten that. Let's go ahead and hope this works, okay? So compile, no errors, and I am going to go ahead and run this. Uh-oh. So we got Armstrong, non-Armstrong, Armstrong. Does that make sense? Well, let's look at our file again. Or actually, let's look at our expected output. This says Armstrong, not Armstrong, not Armstrong. Why are we getting this extra Armstrong? So let's clear that, and I'm going to run this again because it looks like it's working aside from that. And so Armstrong, not. Let's go to our code and look at that. Now, one thing that could be happening is, so this, okay, so let's look at this. My concern is that the length of the list, okay? So the length of the list may be affecting this output. So this is saying that we have 6 results, but our file is saying that we have 5. I get it now. Okay, so they forgot to do the disclaimer. Actually, they did. It says the first line will contain a single integer that indicates the number of lines that follow. Man, I am so dumb. Okay? Not dumb, but I just didn't read that. Okay? And so I should have read that. And let's go ahead and fix that issue. Okay, so So what I'm going to do, since it's working with a list, and we could have used an array at this point because it tells us how many items are in the array, I'm just going to get rid of an item, that first item that tells us the size, by calling sc.nextLine. Okay, so this is kind of a cheating way of doing it. I'm calling it, it's getting the result, and it's advancing the scanner to the next line of actual data. Okay, and so let's see what this does. Okay, so this gives the correct result, but I'm having an issue here. If you see, there is an extra space here for some reason, and I do not know why, but, well, let's go back to this. So I think this may not be exactly right. Armstrong 9, Armstrong 9, Armstrong. Oh. So yeah, Armstrong, not Armstrong, Armstrong. So this is the correct result. But why is Blue Jay giving me an extra space? So let's look at that. I don't know. Okay, so I think this is the issue. It says use a proper IDE. If you want to make sure it won't be there, you can call system.out.flush. Huh. I don't know if that works, but let's see, because that could be. And this is system.out.flush. I don't know if I've ever seen this command. Yeah, so semicolon. So let's see if that fixes the issue here. Okay, so this appears to be a Blue Jay issue. Unfortunately, I don't have another Java IDE. I don't think I have Eclipse. Ooh. Okay, so it's been removed. IntelliJ. Okay, so that's not here. Yeah, I don't have another IDE to test this, but I think this is a Blue Jay issue. Okay, so our implementation is working, but it's Blue Jay that's the problem. So if you submitted this to the judges, they would not see that extra space there. Okay, but otherwise we have the correct implementation and it works. Now, so that is pretty interesting. And we said we were going to extend this, okay? So but do we have time? So we're already at 35, and class is going to start pretty soon for me. So I don't think we have time to extend it like I wanted to. But I think you could easily do this. So we wanted to see how many Armstrong numbers are between 1 and 10,000. And the easiest way to do that is to test every number between 1 and 10,000. Okay? You know what? Let's do it real quick. We're just going to copy this this loop right here, and we're going to change some things up in it real quick. Okay, so this is not going to be list.size. This is going to be 10,000. Okay, and this full number is going to be equal to, we're going to change some things up real quick, and we're going to create a string of the number. Okay, so it works with our already created implementation. So we're going to say string str is equal to I plus this to make it a string. And here we're just going to say, instead of list.getI, we're going to say str dot length, and this is going to be str dot substring. And this num digits, actually I need to, sum full num string, yes. And then we're just going to, well, what we could do is we could output Armstrong, and we'll just get rid of this else. So we want to output Armstrong, oops, the number. The number is going to be I. Okay, and so let's see what this does. No errors. And we may get a lot of output here. Out of bounds, 5. So get I list O. So this is obviously not going to work. This needs to be str. So compile that. Looks like it worked. And here are the Armstrong numbers. So this 153 was that in our list, and this is all the numbers between here and 10,000. And 153 was in our list. 370 and 371 are both Armstrong numbers. That's pretty interesting. And we have 1634, and that showed up as one of our Armstrong numbers as well. So that's pretty interesting. That's all we're going to do today. But they love to put math type problems on these exams. Okay, so getting used to using power and stuff like that is always a good thing. Okay. We're going to have to look at how to create and how to find the prime numbers between, a range of numbers between 0 and 10,000. We would like to be able to find all the prime numbers between that. And they love prime number problems. So if you already have methods of finding the prime numbers within a range, then you're going to have a huge leg up on the competition. Okay, so this is the video for today. But now that school is out, I'm going to be recording a lot more that you could do. It might be more than 2 a week, or 3 a week, or even 5 a week. We'll have to see. Hope you have a good day. Hope you followed along. And what I would do if I were you is I would be working problems. Even though I'm not working them myself, or I have not worked them yet myself. I would be working problems on my own so that when I get to competition, I would just breeze through these district type problems. Okay, so they're not that hard. And when you're not talking your way through a problem, then programming these problems is actually quite quick. Okay, so that's the end of this video, and I will see you in the next one.